We'll take one more example. Two bronze rods and one steel rod together support a rigid beam weighing P as shown in figure. Okay, the stresses in bronze and steel are not to exceed 50 Newton per mm square and 100 Newton per mm square respectively. Determine the magnitude of the load F or P that can safely be supported. Young's modulus for steel is twice that of bronze. Okay, so here this is little different type of example. Here you have to find the load. Okay, the stresses are given, but one clause is there here. The stresses in the bronze and steel are not to exceed 50 Newton per millimeter square and 100 Newton per millimeter square. So you have to calculate the stresses and you have to check whether the stresses are below this value, right? It should not exceed these two values. Okay, stresses in the bronze is 50 Newton per mm square and stresses in the steel are 100 Newton per mm square. So first you have to find the stress and you have to check whether they are less than the given stresses values. Okay, then you can find what is the safe load. How you can do, see, this is the given example. The load is not given. You have to calculate two bronze rods and one steel rod. Okay, here area also not given. They have given 40 into 40 cross section. You have to calculate area, right? So what is the area of steel rod? That is 50 into 50, that is 2500 mm square. Then area of the bronze rod, here there are two bronze rods are there. So how you can take 40 into 40 into 2. So or while calculating P also you can substitute that two value. Okay, let us first find what is the area of the bronze rod. That is equal to 40 into 40, that is 1600 mm square, or you can multiply by 2, that becomes 3200 mm square. Okay, next, length of the bronze rod, that is equal to 300 mm. LB is equal to 300 mm. Then length of the steel rod, okay, this length, full length, here to here, that is 300 plus 200, that is equal to 500 mm. Okay, next, modulus of elasticity of steel, that is equal to twice that of the bronze. So how you can write Young's modulus for steel is equal to 2 times of Young's modulus of bronze rod. Okay, so this is the given data. You have to calculate what is the value of P. Okay, so how you can calculate? First, let us consider the first rule. What is that? Deformations are equal. So first we will find what is the deformation in the steel rod, how the stresses are developed in the steel rod. So deformation is equal to, directly I have written here, that is nothing but PL divided by AE. P divided by A is sigma S. So substitute sigma S into LS divided by ES, right? So substitute the value sigma S, we don't know, into length of the steel rod. The length of the steel rod is 300 plus 200, 500. So substitute that, divided by Young's modulus for the steel. What is Young's modulus for the steel? It is 2 times of Young's modulus of the bronze rod. Okay, substitute, let it be the equation 1. Next, deformation of the bronze rod, that is sigma B into LB divided by EB. Okay, so this is substitute the values sigma B into LB, the length of the bronze rod, that is equal to 300. So substitute, divided by Young's modulus of bronze rod. It is not given, let it be Young's EB. Okay, this is the equation 2. So what the rule says, the deformations are equal, so I equate equation 1 is equal to equation 2. What is equation 1? That is sigma S into 500 divided by 2 EB, that is equal to equation 2, that is sigma B into 300 divided by EB. Okay, so simplify this. What you will get, you can write in terms of sigma S also, sigma B also. I have written both now. Sigma S is equal to, if you simplify, you get 1.2 times of sigma B. Okay, then if you write in terms of sigma B, what you get, 0.833 times of sigma S. Okay, this is the equation you got now after simplifying these two equations. How now? What you have to do here? This is you have to find the stresses which should not exceed the these two values, 50 and 100. So let us calculate first what is stresses in the steel bar. Okay, so sigma S is equal to now 1.2 times of sigma B. This is the what we got after simplifying. Okay, so what is this 1.2 into what is the sigma B? It is given here, stress in the bronze and steel rod not to exceed 50. So that is equal to stress in the bronze rod is 50. Okay, so substitute that into 50. What you will get? 1.2 into 50, that is equal to 60 Newton per millimeter square. What is this? That is nothing but stress in the steel. But what is given here? Stress in the steel not to exceed 100. Okay. Now what is this? It is 60. What you got is 60. So it is less than 100 Newton per millimeter square. So this is permissible. Means this, whatever the value you got, no, it is less than the given value. Okay. So this is safe. So you can consider this value as a stress developed in the steel. So that's why I have written here this is permissible. Okay. Next we'll go to the bronze rod. What is that equation? Sigma B is equal to 0.833 times of sigma S. Right. Here 0.833 into sigma S. What is stress in the steel? Stress in the steel is 100. Okay, substitute that 100. You get 83.3 Newton per mm square. But what is this? It is stress in the bronze rod. But what is the given stress in the bronze rod is 50. So also it is told that it should not exceed 50. Now you got 83.3 Newton per mm square, but it is greater than 50 Newton per mm square. So it is exceeding the 50 Newton per millimeter square. So this is not permissible. It should be less than 50 Newton per mm square. It is greater than now. So this is not permissible. So what you have to consider? Stress in the bronze rod is equal to 50 only. It is not 83.3. Whatever the value which is less value, that you have to consider. Okay. Now after that you have to calculate here safe load. Safe load P is equal to what? PS plus PB. That is the second rule. What is PS? Here only one steel rod. So PS plus 2 PB. Why I have written 2 PB means 2 bronze rods, and I have not calculated 2 times of area here. That's why I have written 2 here. You can calculate here also, no problem. 2 into 1600. Then you don't substitute here. Here only it becomes PS plus PB. Just make a note that. Okay. Now, what is PS? PS is sigma S into AS, right? Because stress is equal to load divided by area, plus 2 into sigma B into AB. Okay, this is 2 bronze rod, that's why. Now substitute the values. What is stress in the steel? Actual stress in the steel is 100, but lesser value you have to consider because it is given not to exceed 50 and 100. So less than 100. What you got here? Stress in the steel is 60. Okay, so consider this value. Okay, for steel. So that's why this is 60 into area of the steel. What is area of the steel? Area of the steel is 2500. So substitute that 2500 plus 2 times of sigma b. What is sigma b? Actually you got sigma b is 83.3, but it is greater than 50, so you cannot consider this. So you have to consider 50. Lesser value you have to consider. So substitute here 50 into area of the bronze rod, that is equal to 1600. So substitute 1600. Simplify this, you get 310 into 10 raised to 3 Newton, or 3 P is equal to 310 kilo Newton. Okay, in this way you can calculate what is the safe load. Okay, main thing here you have to remember that stresses should not exceed the given values, so that you have to take care of that. So how you can do that? First get the equation. After simplifying the deformations, deformations are equal in both the rods, so equate that equation, simplify, write in terms of both sigma s and sigma b, then check the values whether stresses are exceeding the given value or not. Once if you get that, if it is less than the given value, then it is permissible. If it is more than the given value, then it is not permissible. So while calculating the safe load, you have to consider lesser value. Okay, that's why here I have considered sigma s is equal to 60. 100 is more, 60 is less. And in the case of sigma b, we have two values, 83 and 50, but I consider lesser value, that is 50. Okay, into area. So you get what is the safe load. Okay, I hope all of you understood. Thank you.